This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Great. Well, anyway, before going into my research findings, I'd like to give a case study example. And so some years ago when I was completing my PhD at an eating disorders unit, I had the opportunity to interview a young man who I'll call Peter. Now, Peter had always struggled with his maintaining a healthy weight since he was a teenager. But in the last few years, he had become increasingly concerned.
Your presentation?
Yeah, that's fine. Yeah. And so he'd become increasingly concerned with the way that his eating behavior was impacting his health. He described how he'd go through periods of strenuous exercise and diet. For example, he might work out in the morning, restrict throughout the day, but then as soon as he got home, small events that normally wouldn't bother him would cause him to eat amounts of food that he didn't think was possible. He gave one concrete example where in one instance, his supervisor had asked him to stay late after work, and he had planned to go home and just eat the meal that he prepared specifically for his diet. But instead of doing that, he ate everything he had in his kitchen, ordered takeaway as well, and then afterwards had intense feelings of guilt and shame. It took him 2 years to seek out help for this condition, and he was concerned that a pattern was starting to emerge. And what I'm trying to explain in this talk is that this type of phenomenon where seemingly common day events can trigger destructive behaviors is not something that's just found in eating disorders, but it's found across other psychiatric disorders. And I'm going to try to give a summary of some of the research we've conducted explaining neurobiology that may be contributing to this process and how there may be shared alterations across these disorders. So, I'd like to begin by talking a little bit about the extended process of emotion regulation. The unfolding of events that I just described could be interpreted through this lens, in the sense that this model states that there are two evaluation systems in emotion regulation. One is a lower order evaluation system that generally just perceives an event on an unconscious level and gives a certain valence. However, on a higher order, you have conscious cognitive systems that are required to interpret the event and decide what to do with this emotion generation process. They can either decide to react to it, to try to reinterpret it, or to try to see it in a more positive light. Now, the most common ways that emotion regulation is looked at in fMRI studies is looking specifically at the reappraisal or appraisal process. And so it's at this stage when once the attentional resources have been deployed to a salient stimuli, that an individual can choose how they want to react to it, how they want to reappraise a stimuli, and whether or not they want to see it in, for example, more positive light, more negative light, try to suppress their reaction to it. And the most common way to look at this is specifically using a strategy called a cognitive reappraisal, which allows an individual to make this event less distressful over time. Now, the neurobiology of cognitive reappraisal has been used typically using this type of paradigm, which is in a block design. I'll explain through it here. We have here 3 different conditions in this type of paradigm. One just has a participant looking at neutral stimulus, neutral stimuli. Next, in this next block, we have participants looking at stimuli that are meant to provoke negative emotions. And then in the third block, we have participants looking at, our third condition, we have participants looking at negative stimuli, but instead of just allowing these stimuli to elicit a negative reaction, they have to use the previously trained cognitive reappraisal strategies to try to downregulate the emotion that this elicits. And now, because fMRI doesn't give you an absolute measure of brain activity, we have to look at what we call the contrast, which is the difference between activation during regulate conditions versus maintain conditions. This allows us to isolate the brain regions that are either showing hyperactivation, increased activation, or decreased activation during emotion regulation. And like I mentioned here, that's the main contrast of interest to isolate these changes. Now, heaps of neuroimaging studies have been done looking at cognitive reappraisal in different psychiatric disorders as well as in healthy controls. And the most common neurobiological framework to date is the focuses on this model-based emotion regulation involving midline structures such as the pre-supplementary motor area, the dorsal anterior cingulate, working together to compute the value of emotion regulatory actions and to guide behaviors. Whereas other regions such as the amygdala, the PAG, the insula are implicated in emotion reactivity in terms of actually reacting to negative emotions. Other more lateralized regions, for example, such as the dorsolateral prefrontal cortex and the ventrolateral prefrontal cortex, are involved in more of the semantic processing of the negative event that's taking place, as well as keeping the reinterpretations in working memory. And so here we have the results of a meta-analysis looking at regions that have been elicited by emotion regulation. And you can see here a really typical pattern where generally left lateralized regions in the prefrontal cortex tend to show greater activation during emotion regulation, as well as a very clear pattern of increased activation in DMPFC, pre-SMA, as well as the anterior cingulate. Importantly, however, cognitive reappraisal has also been shown to decrease activity in the bilateral amygdala, showing that here we have the PFC regions acting in concert to then reduce activity in subcortical regions. And so one of the first studies I did during my PhD was specifically to look at what are the functional and structural brain features that distinguish individuals with obesity from healthy controls during cognitive reappraisal. Now, first I'd like to clarify that obesity is not a psychiatric disorder. It's a very heterogeneous disorder that is caused by a multitude of different reasons. However, there is strong empirical evidence showing that individuals with obesity more frequently endorse reduced use of cognitive reappraisal and acceptance, which are considered adaptive strategies, and greater use of maladaptive strategies such as suppression. And importantly, ineffective emotion regulation has also been linked to abnormal cortisol patterns, emotional eating, sedentary lifestyle, and sleep problems, all of which we know contribute to the onset and maintenance of obesity. And recent interventions in obesity that have incorporated emotion regulation training have also been shown to improve treatment outcomes as opposed to those that just focus on diet and exercise. And so in this study, we had a group of women who were with obesity, who were awaiting bariatric surgery. As you can see there from their BMI, they had higher BMIs than what you would perhaps encounter in the normal community population. And they had no history of an eating disorder. And as hypothesized, the OB group did endorse higher levels of emotion regulation difficulties compared to controls. However, these differences weren't particularly strong, which reflects the heterogeneity that you see in individuals with obesity, where some individuals might have those emotion regulation difficulties, whereas others do not. And so on to the main results. What we have here is we found that women with obesity presented decreased activity in the ventral medial prefrontal cortex in comparison to controls during reappraisal. Now, this is of interest because the VMPFC, if you recall when I was speaking earlier, is a region that's sort of linked to attributing valence, to attributing value to a salient situation. So we could hypothesize that an individual is unable to recruit these regions when they're required to downregulate negative emotion. They might have greater difficulties in identifying that emotion, greater awareness of that emotions, and therefore being able to manipulate it to their own benefit. And interestingly, what we found was that there was a strong correlation between VMP activation and emotion regulation difficulties, specifically in the obesity group, to the extent that individuals with obesity that presented an activation pattern more similarly to that found in controls were more likely to not endorse difficulties with regulating negative emotions, meaning that there's a potential that if we could restore normalized activity in that region, we might be able to then specifically target these emotion regulation difficulties in obesity. Now, after looking specifically at the VMPFC and the activation differences between that regulate and maintain contrast that I described earlier, we were also interested in looking at whether or not the VMPFC was implicated in differences in functional connectivity, not during the task. And so what we did is we conducted a whole brain analysis using the BMPFC as a seed, and we wanted to see what other regions of the brain showed alterations in connectivity in both groups. So what we found here is lots to sort of work through in this image is we found that individuals with obesity presented decreased activation between the VMPFC seed that we saw before and the temporal pole compared to healthy controls. And so this is an interesting pathway because a lot of studies that have looked at specifically, for example, retrieving memories and trying to contextualize different situations in order to downregulate emotion have shown that the temporal pole is specifically recruited by that process. And so we might be able to hypothesize that if someone with obesity is not unable to recruit the specific pathway between the temporal pole and the VMPFC, they might have more difficulties in being able to provide context or color or tone to a negative situation. Also, we found when we're looking at the white matter tracks that connected these two specific regions, which are specifically connected by the uncinate fasciculus, that the group with obesity presented decreased fractional volume compared to the healthy control group. Now, what's really interesting, I think, especially in the case of obesity, is that it's difficult to understand whether or not this decrease in white matter integrity and this white matter volume is linked to the condition itself, because as we know, obesity, especially in this type of population, is linked to metabolic difficulties and therefore, poorer brain health, or whether or not uncinate fasciculus integrity is a risk factor for developing obesity or poor emotion regulation difficulties. So, however, one of the drawbacks of fMRI emotion regulation tasks is that viewing negative images in a scanning environment doesn't really reflect the situations that patients encounter in their day-to-day lives. For example, image of a spider or a car accident or something like that in most populations doesn't trigger the type of maladaptive behaviors that we see in other psychiatric disorders. If you think back to the example that I gave at the beginning of my talk, here we had a stressor at work, or maybe a thought of sort of getting into the shame spiral, and that's what specifically triggered the binge-eating episode. Whereas here, these types of stimuli aren't necessarily linked to what you would see in a common psychiatric disorder. And importantly, reappraisal training during scanning preparation maps quite poorly onto the techniques that patients are actually taught during talk therapy, such as CBT or cognitive therapy. And so for this reason, we sort of wanted to look specifically more at a more transdiagnostic construct that we see a lot in psychopathology, and that's specifically linked to negative self-beliefs. And so negative self-beliefs are pessimistic cognitions about the self, which often have implications of how an individual views their environment and their interaction with others. And so these evaluations can be statements like, I'm worthless, I'm not good at anything, people are out to get me, people think I'm a failure. And it's quite interesting to see that these types of negative self-beliefs aren't specific to one psychiatric disorder. You ask someone with generalized anxiety disorder, major depressive disorder, or even anorexia, they'll often endorse some of these negative self-beliefs and these negative biases. And so, as I mentioned before, these are often central to triggering the emotional disturbances that are characteristic of multiple psychiatric disorders. And lots of empirical evidence has shown that the extent to which an individual is able to modify their self-beliefs is associated with how well they respond to CBT and long-term reductions in disorder severity. And so one of the main ways that we have participants tackle negative self-beliefs is by using a technique called cognitive restructuring. And so cognitive restructuring has a participant learn how to refute and reinterpret negative self-beliefs. And so, for example, if a participant believes that, for example, they're not good at anything, that they're a failure, their therapist might ask them to think of things that they are good at or think of successes that they recently attained. And so by doing this process, they can try to diminish the impact or the truth that they see in these biased negative beliefs. And so even though this cognitive restructuring process is key to a lot of talk therapies, the neurobiology underlying it remains poorly understood. And so in terms of what we hypothesize the neurobiology of cognitive restructuring to look like, there were two key networks that we thought would be involved. One here is specifically related to the self-referential cognition of sort of how one's view of themselves. And so lots of work by our group has found that self-referential cognition elicits activity in the default mode network. And so most of the time when people think of a default mode network, they think of a task negative state. This is this is a network that generally shows a greater activity when the participant isn't engaging in a task. However, if an individual is asked to do, for example, identify certain adjectives with themselves or to think about themselves, we also see increased activity in the DMN. And some of the key regions that you often see in the DMN, specifically for self-related cognition, is the dorsal medial prefrontal cortex, which is involved in self-directed thoughts and judgments, whereas more posterior regions, such as the posterior cingulate cortex, the precuneus, tend to be a bit more linked with autobiographical memory processing, which when you think about what cognitive restructuring requires is, trying to think of evidence from the past and placing yourself in that context, it makes logical sense that it would involve an interaction of these different regions. And as I was mentioning earlier, with cognitive reappraisal, you probably identified a lot of overlaps between, the cognitive reappraisal process and trying to see negative images in a more positive light, and then also seeing yourself and trying to reinterpret yourself in a more positive light, or reinterpret a statement in a more positive light. And so for that reason, we also thought that we would see increased activity in regions linked to cognitive reappraisal, specifically those more lateralized PFC regions that are involved in semantic processing and working memory. And so the results of this next study that I'm going to talk about is looking specifically at what neurobiology underlying the cognitive restructuring of negative beliefs is. So here for this specific task, study, we developed a new paradigm, which had participants look at a series of negative statements that were drawn from Aaron Beck's CBT manual. And so first they were presented with this negative statement, for example, I'm not good at anything. And next within the scanner, they had to decide whether or not they wanted to challenge the negative statement or repeat that statement to themselves. And below they had a counter explaining how many times they could either challenge a statement or repeat it to themselves. And so that then ensured that there was an equal number of blocks for each condition. And then they had, for 12 seconds, they either challenged that statement or they repeated it. After cross-fixation, they then went back and saw another statement. And our main contrast of interest for this was to look at the difference between an activation between challenge blocks versus repeat blocks. And so for our study, we recruited 42 healthy participants without a psychiatric disorder. They were generally in their mid-20s. And we also used the PTQ to look at repetitive negative thinking in order to have a sort of more behavioral validation of how often these individuals endorse these negative self-beliefs. And we conducted a study using the 7 Tesla fMRI facilities that we have here on campus. So Tesla doesn't, here in this case, is referred to an electric car. It refers to the strength of the magnets that we use, the field strengths within a scanner. So most scanners using research nowadays have 3 Teslas. We're fortunate enough to have a 7 Tesla here. And so this allows us to have higher temporal spatial resolution, improve signal to noise ratio, and importantly, to detect effects in subcortical regions that are quite difficult to reach with a regular 3T scanner. And we were specifically interested at looking at the Mediodorsal thalamus. And so normally when people think of the thalamus, they think of it, I remember hearing this when I was an undergrad, as the switchboard of the brain. This is where sensory information from extremities and such get relayed to your sensory motor cortex, and then similarly where motor responses are generated and they get relayed. But what makes the mediodorsal thalamus unique is that it has projections almost exclusively to the prefrontal cortex. And it's especially large in humans compared to other mammals in the sense that it's thought to underpin higher order function. And what we see is if someone has a focalized lesion to the mediodorsal thalamus, they present cognitive deficits that are similar to those that you would find if someone had a lesion to a prefrontal region, which makes us think that you can't really understand higher cognition without understanding how the mediodorsal thalamus interacts with the prefrontal cortex. And so what we wanted to look at here specifically was to see how the mediodorsal thalamus interacted with these other regions using a technique called dynamic causal modeling. So I won't go too much into what DCM consists of, but for example, in the first study that I showed, when I described functional connectivity, all that basically tells us is which areas of the brain are co-activating or co-deactivating with each other. And so from that, we can infer that they are working together. However, it doesn't really allow us to know whether one area is having a causal effect on the activity of another area or vice versa, if it's having an excitatory effect, if it's having an inhibitory effect. And so what DCM does is it looks at the time series events, basically that would be signal that we get from our fMRI scanner. And using a Bayesian model comparison method, it allows us to decide which configuration of a model space best explains the data, and therefore how one region is most likely impacting the activity or the connectivity on another region. Yeah, so happy to talk more about DCM after the talk if that would be helpful. And so we'll get straight into our fMRI task findings. This is from a challenging negative beliefs task, as I mentioned before. And so here we have areas that are showing greater activation during challenge blocks versus repeat blocks. And so we see a really interesting activation pattern in the sense that, yes, we see activation in regions that are linked to the DMN. So for example, these midline regions here, the VMPFC. And we also see activations and that are more linked to, for example, cognitive reappraisal. We have this really typical left lateralized DL and VLPFC activation here, and as well as activation in the subcortex, specifically in the caudate. And going back to the mediodorsal thalamus, you can sort of see here, we have a really focal activation there, right there on the mediodorsal thalamus. It's in the sense that it's showing greater activation when the participants are asked to challenge negative beliefs versus just repeat them to themselves. And so what we wanted to do then was to see what effect the mediodorsal thalamus was having on these different regions that were elicited by cognitive restructuring. So we set up this model space that basically allowed us to test the modulatory effects of cognitive restructuring on the effective cognitivity from the mediodorsal thalamus to these different regions. And so here we have a diagram of our winning model. And so in line with animal literature that has shown that the mediodorsal thalamus plays a role in sustaining activity in the PFC, we found that it had an excitatory effect on the main regions in our model space. And interestingly, we also saw evidence for a bidirectional effect from the medial prefrontal cortex back down to the MDT, which suggests that this may form part of a relay loop, whereas the PFC is acting in concert to decide, okay, whether or not they need to continue to sustain that activity and therefore feed that information back to the MDT, which then continues to act as an integration hub of the different inputs being received from the mediodorsal thalamus, or whether or not it needs to stop and shift attentional resources elsewhere. And we were also interested in seeing whether or not the extent to which a participant was able to, for example, manipulate or modulate these different pathways could predict whether or not they were more likely to engage in repetitive negative thinking. And so what we did is we used this this tool called leave one out cross validation, and we were able to see that by iteratively testing all these different configurations and testing and leaving out different participants, that individual VMPFC to mediodorsal thalamus connectivity strength can reliably classify participants' perceived negative thinking scores, meaning that the extent to which an individual was able to modulate that pathway meant that they were more likely to engage in repetitive negative thinking. So what now? So the last study I showed was just specifically in healthy controls. And one of the things that we're really interested in looking at in our group is seeing whether or not the CNBT can predict treatment outcome in participants with a mood disorder. And so currently we're recruiting participants from the psych clinic here at UML campus. And we want to see first whether or not there is clear differences in functional connectivity and brain activity in clinical participants versus healthy controls, and also to see whether or not their ability to engage in cognitive restructuring is able to predict their ability to respond to CBT, because as you know, CBT is largely ground in a lot of these talk therapies in this restructuring process. Another project that I'm working on now, what's sort of getting started, is called the NeuroWIRED project. And so the NeuroWIRED project, this is piggybacking off a larger MRFF project, is it's a web and app-based prevention, early intervention for adults with eating disorder symptoms. And it involves them receiving a mobile delivered intervention over 10 weeks. That includes CBT, psychoeducation, acceptance therapy. And what we're going to have here is before participants begin the therapy through this intervention, is we're going to have them conduct the CMBT test and a few other tests I'll describe later. And we're also looking at some specific measures that we think are linked to challenging negative beliefs and some of the symptoms that you see in eating disorders and binge eating behaviors, specifically like compulsive eating and some other binge eating symptomatology measures. And so these are some of the key processes I had mentioned at the beginning of the talk that contribute to binge eating, negative self-beliefs, repetitive negative thinking, as well as compulsive eating, which I'll describe later. And so we'll have participants conduct the challenging negative beliefs test, as well as this new paradigm that we're currently pilot testing, which is a stress reactivity task. And so what we have here is we have participants in the scanner, and they're going to be receiving food stimuli through a device that we call a gustometer. And so while they're lying in the scanner, they have a mouthpiece in their mouth, which is similar to a pacifier in the sense that they just, when it says we're going to receive food, they can then suck on it, and we can see how their brain reacts to this. And so we'll present them with a food cue, which is either going to be a chocolate milkshake or a neutral water solution. And then they can now anticipate whether or not the food's going to come. We have a specific food cue condition here. It gets delivered. And then we ask them to give using a visual analog scale to state how well it tastes. We're provided with a rinse, another cross fixation, and then we continue the block again. And so it's a very simple paradigm in the sense that we only have two conditions, which is milkshake versus neutral solution. However, what we're going to have here is we're going to have two runs within the scanner. So we're specifically interested in looking at how participants react, participants with binge eating react to food intake under stress conditions and under neutral conditions. And so in the first run, we'll have those participants do this task without any sort of stress induction. However, in the second run, before they begin the task, we're going to induce stress by having participants conduct a series of very difficult math problems. Before they get into the scanner, we tell them, even though they've been briefed beforehand, that their performance in the math problems does not implicate their participation in the study. As those problems get increasingly difficult, we can see that they'll become more and more stressed out. And then as soon as we sort of have seen that they've reached a limit with doing these math problems, we then do the stress reactivity task again. And so we're specifically interested in looking at whether or not reactivity during the stress paradigm is able to create a distinct phenotype of participants with binge eating that are, for example, more driven by negative affect, more driven by stress, or for example, others who are more driven by hedonistic aspects of food, reward, food cues, etc. And so using computational methods, we're hoping to be able to predict which participants are going to be most likely to respond to the E intervention, or which other participants might benefit more from a more targeted intervention. And that is it. Thank you so much.
Thank you so much, Trevor Steward. That was a very, very comprehensive system, Mike.
Yeah.
Here we go. Very, very comprehensive body of work. I wonder, with the earlier work related to obesity, there was the finding of decreased connectivity between the ventral medial prefrontal cortex and the temporal pole. And you mentioned that it might be related to risk or to epiphenomena owing to illness factors. Have there been any studies examining individuals at clinical or genetic high risk to determine whether they also display connectivity deficits?
Yeah, that's a really excellent question. And so there's been some great work looking specifically at adolescents, because the us fasciculus is one of the last fasciculi to develop during adulthood. And so there's been studies linking that individuals who are premature and developing that that pathway in terms of developing those white matter tracks are more likely to have better emotion regulation strategies, as opposed to those who are later. They tend to have more destructive behaviors. It wasn't specifically linked to obesity. It was more linked to acting out in the context of adolescence in a more general sense. But it's an interesting idea in the sense that this pathway might be really important in terms of brain maturation, and then down the line linking to some behaviors that could be a risk factor for obesity. Yeah.
Thank you very much. And just one quick neuroimaging question for the neuroimaging people out there. The subcortex is notoriously difficult to parcellate, and we've had, of course, Dr. Yetian, who's dedicated a large portion of her thesis to it and produced a new subcortical atlas. So I wondered what your strategy is for parcellating these difficult regions.
Yeah, it's very tricky, and thankfully this is not something that we do alone. We have received a lot of support from the folks over at the Melbourne Brain Imaging Center, and so they've helped us develop specific sequences that help us to isolate these regions. And then depending on, it also really depends on what your specific research question is. If you're looking at a specific, one specific region, you might use an atlas, whereas in other situations, you might have to even hand draw it. It really depends on what you want to look at.
Yeah. Okay. Fantastic. Yeah. Thank you. Now, there are questions.
I wondered if we had any thoughts from the people online or thinking about what we're going to ask.
Yeah.
Okay.
Just a very small question. Great talk. With your the negative self-belief part, I was just curious about the strategy of letting them decide, decide what strategy rather than just saying, you're going to now reevaluate or now you're going to repeat it. Like, what was the rationale? Yeah.
So this is paper to be completed at some point, is we're really interested in looking at the neural pathways involved in that choice element and deciding whether or not one wants to make the effort, one wants to dedicate cognitive resources to approaching this negative belief and trying to challenge it, or if they're going to engage in this sort of more avoidance behavior and decide, I'll just repeat it to myself, even though I know it's probably not true. And so that's a separate study that we're going to probably do down the line.
Can I have a max number of times they can do each choice?
Exactly. And so, and so we ask them, or we tell them beforehand, like, you have 8 times you can repeat, 8 times you can challenge, and then the paradigm itself has a little counter on there that tells them, okay, this is how many times you can challenge this left, this is how many times you can repeat it.
Just on that, I can't remember how the data fell out, but what was the variability like for the different questions?
Yeah. So that's a great question. And because one of the reviewers did ask that, and there was no significant effect, and meaning that and this is a bit different. It's not using a regular p-value, it's more like using a chi-square test, but done to a large extent because it's a yes/no type of thing. But there was no effective question on whether or not a participant chose to challenge or repeat it. I mean, it was just as likely that if we pulled out random question from the task, that they would either challenge it or repeat it. Yeah. And from a behavioral standpoint, also worth mentioning that we had participants pre-scan ask them to endorse how much they agreed, or to report how much they agreed with these statements, and then post-scan ask them the same thing. And there was a significant effect in that the statements that were challenged had lower levels of endorsement following scanning. Yep, Sam.
I had a question about the subcortical lung feature that you showed in one of the figures, and it was really tiny. So I was thinking, like, I'm sure that probably 70 helps with detecting those smaller regions, but did you use any specific power analysis before starting, to kind of reset the sample size that you would want to have to be able to detect that effect, or does the sample size play a role in detecting that?
Yeah, well, we did some pilot testing, which was the key. I think especially with the new paradigm, you never know what sort of activation pattern you're going to see. And so the key here was we did pilot testing. We were able to see that, okay, even with, I think we had 6 participants in these first pilots, of course at a lower threshold, but then you could then after that do a power calculation and see like, okay, we'll be able to detect effects in this region once we get up to a certain threshold. And another thing that I didn't mention here, it's a bit more on the neuroimaging side, is in order to really isolate this region, we purposely use a smaller smoothing kernel. Because as you know, these subthalamic nuclei or these thalamic nuclei are quite tiny. And so if you throw an 8mm kernel on there, there's no way you're going to be able to not detect or get activation from the adjacent regions. And so here it's a 1.6mm voxel, and then our smoothing kernel was only 3.2. And so that helps us ensure that we're not, when we're looking at our connectivity or our activation, obtaining values from adjacent regions.
Maybe you could generally, just extending that comment on the power gain you're getting. I mean, you're doing nice work with Lindsay at the moment.
Yeah.
You're showing the gains generally that you get at 7 versus 3T. I think it relates to that question.
Yeah, that's another good point, is with 3T versus 17. This is a project that Lindsay, my honor student from last year, is working on, is using a block design, not too different, but even more robust than this design. It's very simple and consistently showing effects that we've been able to see that compared to a 3T scanner, with 7T, you normally need about half the participants in order to reach an FDR threshold on a whole brain level. It does vary across regions. For subcortical regions, the effects aren't quite 50%. It's a little bit less, but still you're able to easily detect effects in the cortex with much fewer participants than with 3T. Yeah.
Just on that again.
Yeah.
Just going to the design that you've got for the, what are you calling the experiment with the
Oh yeah, the gastometer one. Yep. There we go.
Yes, I know you're having you're still getting it all set up in the machine, but have you done any piloting?
Not in the scanner. We're just getting the gastometer run.
Yeah. So I wonder whether, given what we've seen with the amount of blocks you need to get, like what we're just talking about, whether there's some efficiencies you can make there as well,
Yeah.
or whether
that's something that we're really we haven't pilot tested it yet to see that, but because we're doing 2 runs, I wouldn't be surprised if the number of blocks that we need, especially since it's such a simple, stress greater than neutral or water greater than milkshake. It's 2x2 in the design, that we probably wouldn't need as many blocks as we anticipate. And that would obviously for the participant make it a lot better in terms of reducing the time that they're in the scanner and the amount of milkshake we have to prepare. Yeah.
There's a question here
Yeah.
from Dr. Eva Guerra-Haynes.
Oh, hey.
A really interesting talk. Trevor, I was wondering, whilst the medial dorsal thalamus seems to have an excitatory role during the challenging versus repeating of negative self-beliefs, is there a key signature of activation, thalamus or otherwise, during only the repetition of negative self-beliefs? And does that then relate to an individual's ability to then challenge a negative self-belief?
That's a really excellent question, Eva. Very, very good. And so, yeah, we did specifically look at the rep greater than challenge block. And there was a few reasons for that. One is that although we can see with the rep greater than challenge blocks, regions that, show greater activation, that have a signature compared to challenging, we didn't feel comfortable saying specifically that this is your brain activation during repetitive negative thinking, because in fact, it's brain activation during repetitive negative thinking versus challenging negative beliefs. And so if you really want to isolate repetitive negative thinking, you would have to probably, change the paradigm a bit in the sense that you have, okay, participants repeat these negative statements to yourself, participants here's a neutral statement, and then compare those two. Yeah. And so that would be a different paradigm, whereas with this task, we specifically want to look at that cognitive restructuring process as opposed to the repetitive negative belief process. Yeah, but no, it's a really good question.
I have just a little question out of curiosity for this task.
Yeah.
Do you screen for mathematical competency to?
No, so it's actually something where the maths isn't really it's just to stress them out. And so we have the different levels of which, at first, I think it was 999 minus 17 and just start doing it in the scanner.
So it increases.
Increases. And then what we have a script and we say things like you're performing below average and just try to really, and even though they're briefed and they know that it's part of the experiment, participants still get stressed.
Wow. Well, it seems scary to me, but I imagine there are some people for which it would be
Yeah, pretty
not
easy.
stress inducing.
We just keep on making it harder and harder.
Yeah.
Yeah.
Fair enough.
Yeah.
Are there any
I
questions?
think that was, that's pretty much it.
And how about from the floor? Any final questions?
Jared?
A quick question, right, just on the same with summary
Mm.
class. I mean, given that you said, oh, maybe there'll be kind of additional blocks available if we don't need all those blocks, I was wondering if you're also perhaps considering changing the rating scale in itself. Like, obviously, it's tapping into more hedonic construct at the moment in terms of Python rating, but you know, what about things like behavioral urges or wanting related ratings?
Yeah, no, it's tricky with these visual analog scales in the scanner. To be honest, it is how pleasant does it taste? The main reason why we're including this is we need to have a behavioral validation showing that milkshake is more pleasant than water. It sounds obvious, but you have to have that. And that's what this visual analog scale is going to allow us to do. Whereas if we were to ask things, for example, you know, how much are you craving the milkshake now? At least in my experience with other paradigms, you don't often see that much of a behavioral difference between groups, especially in the scanning context, because you know, these aren't validated measures. They're not, and it's very difficult within a scanner. It's the noise. They're responding on keypad to present them with a series of questions as if they were doing a questionnaire online or something like that. But not to say that's not something that we wouldn't want to tap into, but it's probably more apt to look at either, or more apt to look like outside the scanning context. Yeah.
What about autonomic reactivity? It's all about, given that we've got all the kits set up, we're using in other experiments.
The SCR.
Kind of interesting in this task as well, right?
Yeah, that's something where I think with the SCR especially, we're and other measures, maybe heart rate variability would be really apt for this, is mainly to see that stress reactivity. To be honest, I wouldn't be surprised if both controls and participants with binge eating or obesity show greater autonomic arousal during the stress condition, and that there's no differences there. You'd hope so, but I don't think you would necessarily see a greater difference between the two groups.
Yeah.
However, having those measures would be a really solid way of showing that, yes, stress is actually being induced by this mass problem. Other things more around the sense of, for example, and this is down the line, is whether or not that autonomic response reduces faster in one group versus another. And for example, maybe you see that in the healthy controls, okay, you know, at the beginning of the run, heart rate variability is really, really low, but then it starts to normalize. Whereas with the binge eating control group, during the entire run, it lasts the entire time. And so that's something that we were really interested in seeing more in terms of that response to the stress.
In addition to the tonic stuff, even the Q reactivity would be interesting, but that'll mean that your design will need to be a bit tailored.
Yeah, maybe longer blocks, that kind of thing. With the Q one, we're not really sure yet how, because part of us wants to, so we know what there's the whole wanting versus liking argument. And so with the food cue, we're tapping into that food wanting aspect, with the liking something they actually receive the food stimuli. But if we wanted to, like you were saying, look at that autonomic response, we'd have to probably change the design a bit more, have longer delays between them, but it's doable.
Yeah, I think.
Yeah, first we have to get this gestometer run, which has been a challenge in itself.
Thank you again for a very informative talk, Trevor. Just to let you all know that the next upcoming speakers will be up on the department website. And thank you all very much for joining. So last round.